I will leave the floor to our friend Sid to talk to us about measuring and shaping the effects of AI. Sid, the floor is yours.
Good morning, everyone. It's a pleasure to be here. Thank you, Saudi, for the kind introduction. As Saudi said, I'm going to talk about measuring and shaping the effects of AI in society. More specifically, what I'm going to talk about today is going to be the implications of AI agents for knowledge work. And by the way, my full name is Siddharth, but everyone feel free to call me Sid. Everybody does. And before I get into my talk, let me just say thank you. Thank you to this institute. Thank you to Saudi. Thank you to the faculty, staff, everybody. I've only been here 3 or 4 days. It's been incredibly stimulating already. I can't wait to see what the month has in store for me. It's going to be a fun ride. Okay, I thought I would start by answering a simple question. Who am I? I thought I would introduce myself to you all. I am a computational social scientist. That is a very fancy way of saying I use computer science to understand human behavior. I'm also a senior principal researcher at Microsoft, as Saudi said. For those of you who are not familiar with Microsoft research, the main focus of my job is to conduct research. I get to choose the research questions I work on. I get to set my own research agenda. I am judged by the quality and impact of the research and the science that I execute. I find that Microsoft is a wonderful, fascinating source of problems and a wonderful, fascinating source of data to analyze. I would consider myself a question-driven scientist. I use whatever appropriate methods, whatever methods are best for the question I'm asking at the time. I've done behavioral experiments. I've done large-scale data analyses. I've done mathematical modeling, and by that I mean theorems and proofs. Surveys. I've analyzed quantitative data. I've done ethnography. There's probably even a methodology or two I've forgotten here. So that's a little bit about who I am. And I thought I would just, since I am a question-driven scientist, I thought I would just quickly tell you a little timeline. I made a little timeline for you guys of the research questions I've worked on in my career. I started off by looking at how does the structure of the networks that we're a part of affect our behavior. Later in my career, during my postdoc and my time at Yahoo, there was a very common computational paradigm called MapReduce. It's a way to distribute massive computation across many different machines. And I had a 5-year program on what is efficiently computable using that paradigm. Sean yesterday mentioned that his work touches on cooperation. That's something I also studied for about 6-7 years. More specifically, how do you sustain cooperation when people are allowed not just to cooperate or defect, but also to choose who they're playing with? And to do that, to execute that research program, I had to conduct a methodological innovation, and I was a pioneer of these virtual labs. That is to say, we took experiments that were typically done with undergraduates in a laboratory at universities and moved them online using crowdsourcing sites. And then finally, after that, my expertise in crowdsourcing led to me asking this question of what is the lived experience of on-demand crowd workers or gig workers? And that culminated in me co-authoring a book called Ghost Work. It's about the humans that power modern AI systems. It came out in 2019. And then shortly thereafter, after the book came out, COVID-19 hit, and I shifted my research program to understanding what's the future of work. And then not long after that, ChatGPT was released, and then I started focusing on what are the effects of AI in society, and also what are the effects of AI on the future of work. So that's a little bit about who I am. During my time here, if anybody wants to talk about any of these questions that I've worked on, or they overlap with what you've worked on, I would love to do so. Okay, I have 3 goals for this talk. First, I'm going to outline what I'm going to work on this month. Second, I'm going to be clear about what I need to do more thinking and reading on. And most importantly, I want to get your thoughts and feedback. I have a whole month ahead of me, so I want that to be informed by the quality of scholars in the audience today. So let me start with a simple question. What do people use AI for? Okay. So when you think about a user's interaction with an AI, the first thing you have to realize is there's 2 parties. There's the user and there's an artificial intelligence, or the chatbot. And I'll give you an example of what I mean here. the goal that the user has can be different than the action the AI performs. And that's okay. And I'll give you an example taken from the real world. A very common use case is people copy and paste an error message that computer's given them and put it into a chatbot. And then their goal is to resolve that computer problem, to fix this error message. The AI, at least when they first came out, chatbots couldn't solve these problems on their own. All they could do was advise you on how to fix the issue. So the chatbot's action was to either explain the technical details of a product or a service or advise others on the design or use of a technology. It wasn't actually to solve the problem because it couldn't do that. And this little split is gonna come up in the next couple slides. And what we did was we analyzed over 100,000 actual conversations with between actual humans and chatbots to understand what do they do, what do they use AI for. So on the left-hand side here, I'm showing you what were the top user goals. And as you can see in red, the primary use case, the primary user goals were to learn things. That is, to gather information, to obtain information about goods and services, to maintain your knowledge, etc. Then if you shift your focus to the right-hand side, you can see that the primary AI actions were to communicate. That is to say, to respond to the user's problems, provide information, provide assistance to the user. And secondarily, the top AI actions were to teach or to explain, that I'm showing here in purple. So what we see is that the AI was acting in kind of a service role to the user. The user was trying to gather information, and the AI action was trying to provide that information or teach that information to the user. Okay, all right. Oops. So to answer the question that I set out a few slides ago, what tasks are people using AI for? What we found is they're predominantly using AI for knowledge work. This is what me and my research team found back in 2025. And what do I mean by knowledge work? I mean the creation, processing, and communication of information. And we saw that AI acts in a service role. Recently, and just a few months ago, me and my research team, we replicated this study, not just for ordinary users like you and I, but also for enterprise users, like those that might be in a company or in a corporate setting. And qualitatively, the same results hold. People were largely using these for knowledge work, and the AI was acting in a service or sort of assistive role. Okay, great. That's a little piece of background, but now I want to talk about agents and their implications for knowledge work. So let me just start out. What is an agent? So let me give you a definition taken from a classic AI textbook. An agent is a computational system, and in our case, what I mean by that is an LLM or a large language model. And that computational system pursues goals on the behalf of a principal, and in our case, that principal is going to be either a human or another agent, by perceiving an environment, deciding what to do, taking actions over time with some degree of autonomy. And that last bit is one of the crucial parts, some degree of autonomy. And that degree of autonomy sits on a spectrum. So when chatbots first came out, they didn't have much autonomy. At most, they could kind of search the web for you, but that's about it. Nowadays, what we're seeing, what I'm seeing sort of anecdotally with my friends who are software engineers, is they say things like, I haven't written a line of code in 6 months or 9 months. I have agents writing all the code for me. I have agents running all the test suites for me. I have agents checking in all the code for me. I have agents code reviewing for me, et cetera, et cetera, et cetera. So this degree of autonomy is sort of like scaled up as the months have gone by. Agents right now, to my knowledge, anecdotally, are mostly used still in the software engineering industry. However, it's in the next month or in the next year or so, I think it's going to be much more prevalent to penetrate into the sort of everyday workflows of people. So the second you have a human working with an agent, what that human does is they architect a workflow. Let me explain what I mean. This is a sort of common example use case of a human working with an agent. So a human comes across some very large code repository. Say it's quite big, millions of lines of code. No way one human could understand it in one sitting. So they pass this code to an agent. to get some understanding, to gain some insights as to what this code does. Then they decide, okay, I think I understand what this code does. Now I need to sort of refactor it. I need to maybe change its purpose a little bit, make it more modular, something like that. And then I want to test how it's refactored. So they refactor it, they test it, and they pass that to an agent again, spits out a new code, a new chunk of code, and the process sort of repeats. So the point I'm making is when you work with an agent, the work is often multi-step. It's not a single prompt. And the work and the context of the work often evolve over time. That's what makes it quite a bit different than just sort of working with a chatbot. Excuse me. The other point I'd like to make about working with agents is that they turn knowledge workers into workflow architects. So before ChatGPT, if a knowledge worker had to do a task, they simply just did the task. But post-ChatGPT, what we see is predominantly most knowledge workers are doing the task with AI assisting, as I mentioned a few slides ago. AI is acting in that assisting or service role. But now what we're seeing is that in this new agentic world, knowledge workers are actually just designing the workflows of agents to do the task. So they're sort of delegating the task to the agents, building that workflow for the agents to work together. The agents do the task and report back to the user. Now, these workflows that I'm mentioning can get fairly complicated fairly fast. So for example, in the top here, I have the same sort of workflow that I outlined earlier. And you could imagine a scenario where the code that comes out of that workflow gets applied to some data by an agent. And that data does some analysis. And maybe they iterate back and forth and change the code and analyze the data a few more times. And that gets the user some insights. The user then passes those insights to another user who takes an action or another user who takes a managerial decision. So the point I'm making is these tasks can sort of span people and span systems. This all requires coordination. And furthermore, they require coordination across teams, across organizations, maybe even across companies. So these workflows can get very complicated. You can easily imagine workflows composing with one another, interleaving with one another, intersecting with one another. Oh, I'm not sure how to erase what I wrote. Here, let me just, anyway. Oh, there we go. Sorry about that. Just erase these. There we go. So you can easily imagine a scenario where you can imagine firms having many humans and many agents intersecting and working together in these complex networks of complex workflows. But there's something going on here under the hood. The goals of every human, every agent need not align with one another. I'm already seeing this sort of anecdotally among my colleagues. What I've heard anecdotally is I'm working on a chunk of code and I'm working with some agents to make that code do something. My colleague is working on that same chunk of code and he's working with some agents to make that code do something else. And our agents are sort of conflicting with one another and overwriting each other and working at cross purposes. And that can add complexity. And this is one of the things that I might focus my month on here, is the complexity of an ecosystem of agents. And I'm going to talk about two frameworks from the literature that sort of give us a starting point to study this complexity, but fall a little bit short of the needs that we have today. So the collective intelligence literature is a fascinating literature, and it studies fairly simple automaton like ants, for example, and how they follow a few simple rules. For example, ants, when they're foraging for food or searching for food, they only follow like 5, 6, 7, a handful of very simple codified rules. But they can, when you get many of them together, they exhibit this very complicated search behavior that leads to a successful column. But the interaction between the ants is fixed. It's fixed according to these rules. And in this scenario where there's a very simple automaton with fixed interactions in large scale, the collective intelligence theory does give, rules for predictability. It does allow you to predict how a system would behave and the emergent dynamics of that system. Game theory, on the other hand, is almost like the dual for a moment, if you will. And in game theory, the agents are very, very complicated. In fact, they're completely rational. So they're very complex. Each automaton is very complex. They can perform very complicated computations and to find the most rational solution for themselves. But generally in game theory, the number of agents is pretty small, and their interaction is codified according to the actions of the game, specified according to the actions of the game. And game theory does give good predictions, provided all the agents are rational. But at the bottom row here, that's where we're going to be shortly in this multi-agent AI world, where the components are, again, extremely complex, but they're not just complex, they're also opaque. Because these agents are built on large language models, many of these large language models are black boxes and you cannot open them up and study them. Secondly, they're going to be interacting at large scale. It's easy to imagine a world where each person's interacting with dozens, if not hundreds of agents. The interaction between the agents is often in natural language, and it's often even underspecified in the sense that it's very difficult for people to specify every single scenario that an agent might encounter and how they might behave in that scenario. So often the specifications can be underspecified, which can also lead to complexity. And so there's very little theory here, and we're sort of out on our own as a scientific agenda to understand how ecosystems of agents might behave. And sort of understanding this and beginning this endeavor might be one of the things I work on this month. And one of my to-do items is to understand, are there any other theories that could help? For example, statistical mechanics or other branches of science that I'm not aware of as of yet. And the second research question that I might work on for the month that I'm here is, what is the role of expertise in a world of agents? So you need expertise to determine, first and foremost, to determine, is a problem worth solving? Should I build a workflow with agents to solve this problem? Okay, great. Well, given that you've decided, your expertise told you, yes, this is an important problem and I should solve it, people often encode their expertise in that workflow. That is to say, they encode their expertise by showing how to break up the task, where to checkpoint the task, what kind of data for the workflow to output so they can monitor the task, how to debug the task. So if the workflow is not generating the right output, where along the chain of the workflow might it have broken down. It's another place where expertise is necessary. And one thing that we're starting to see, and we will see more and more, is workflows can be abstracted and applied across different domains of expertise. For example, if I, as a computer scientist, implement some sort of statistical workflow to work on my data, Sean or Chris or other scientists here might apply that same workflow to their data, and that so the workflow might transfer from one domain of expertise to another. So these agents might sort of diffuse that way across different domains. But one of the questions I want to think about is, if we lose the ability to do these tasks ourselves because we're offloading them and delegating them to agents, will we also lose the ability to specify these workflows, to break these tasks down and to validate these workflows? In other words, will our expertise erode because we're delegating so much to these agents? So that's a little bit about my work and a little bit about what I'm going to work on today. The logical flow I've sort of presented to you today is very, very simple. People predominantly use AI for knowledge work. Agents turn those knowledge workers into workflow architects. And that leads to two sort of research questions that smack you right in the face. First, how do we understand and control the complexity of ecosystems of agents? And second, how do we maintain our expertise as we delegate more and more tasks to AI and to agents? Thank you for your time and attention, and I'd love to open the floor for comments and questions.
Thank you very much, Sid, for this. And these are questions that we're actually facing right now. What you described is exactly the current type of problem that we're doing on an everyday basis when we're using AI, and we're realizing that we have to construct at the end of each session minutes for knowing what we've been doing and transferring to others, and continuity handoffs either to the system, to the LLM itself, or to ourselves. And just two comments here. The first one is about the set of theories, right?
Yeah.
And in fact, This is just a new form of the old problem of
Yeah.
cooperation and societal labor division, right?
Yep.
And as you said, it involves a lot of complexity, but there are a series of theories handling this. You mentioned distributed cognition. I mean, Ed Hutchins' work, who was actually a fellow here, and using activity theory, situated action. And that affordances and institutional economics, there are some synthesis, and I mean, like installation theory, and we can talk about that stuff and how these things explain what societal solutions have been given to the same kind of problem, except that the agents were all human, right?
Yeah.
And some were machines. And one of the, I mean, technical solutions that there are is that there is a distribution of what is supposed to be done between the physical affordances that are built within the systems. And we could say that's the rules of cooperation that would be inbuilt in the LLM agents and the alignment rules that they have. But others are simply, rules of role distribution and in the labor division. The second aspect about the loss of expertise, I mean, we have here at the Institute a working group with the vice president in charge of AI in our dozen of universities that are the members of the Institute. And we are exactly confronted to this, is what are the skills that we must now teach the students for the next step? And what we know now for sure is that if you want to be able to use these agents, it's fantastic if you know the domain, but if you don't know the domain, it's a catastrophe, right?
Yeah.
And
Exactly.
so not only they will continue to have to learn about the domain, but they also will have to learn about how to use the agents. So it's not a different way of learning stuff. It's just more learning, unfortunately. And
Yep.
and we'll have to. The big problem is evaluation, right? We have
Yep.
to make sure that with their own brains and unaided, they are still able to know enough about the domain to be the architects. And I love your turn about this of the agent's work. And but I don't want to speak too long. I see there's Chris and then there's Sean. Chris.
So just before we get to those questions, sorry, just two. I just want to respond to your 2 points, your comments. First of all, regarding the theory you mentioned, yes, let's have a chat over lunch. I want to dig into all that.
Yes,
Okay.
definitely.
Secondly, another thing that I didn't talk about in my talk, I just had to cut it for time, was another idea would be to look at sort of some historical examples, for example. Like, for example, like, we all use calculators. When I was in high school, we used like graphing calculators, but we still had to learn addition, subtraction, or how to graph a parabola by hand. So what are those things that we still need to learn? Then once we learn them, then we can offload. Like, another example would be, I did a study where we interviewed Microsoft employees about how they use freelancers. And if you know how to do the task, you know how to define the task, you know how to break up the task, you know how to hire for the task, you know how to pay for the task. So the freelancer does it and everything goes smooth. If you don't know how to do the task, you don't know how to describe the task, you don't know how to break up the task, you don't know how to pay for the task, you don't know how to hire the task, and everything goes sideways. And I feel the same thing is going to happen here with the agent. So yeah, but we can talk more about that as well. And if people have ideas for a good historical analogy, I'd love to hear them. But I think maybe Chris had his hand up first, so shall we?
Yeah, and Sid, I think that's a great point. I think that the discussions now about AI in the classroom are similar to discussions a couple decades ago about whether or not students should be using calculators. That's a good point. So I had 2 questions. You want me to ask them both and then you answer, or should I ask them?
Dude, I'm getting old. Just ask them one at a time.
Okay. Well, I think you addressed this somewhat in your discussion of expertise, which I really appreciated. But when you talk about knowledge workers, I think the examples used were software engineers who are probably just down the hall from you.
Yeah.
And actually, a lot of the discussions I hear about how AI applies to work, I think is referring to software engineers.
Yeah.
And I'm curious how much you're accounting for differences across different types of work. You mentioned the findings might extend to other areas, but how much are you taking into account people that are like cinematographers or,
Totally.
So can you answer that?
Yeah, absolutely. So I want to make a little separation between the two parts of my talk. The first few slides, when I was like, what do people use AI? That was done on a random sample of 100,000, actually 200,000 conversations between humans and AIs, just regular people. Not, some, yes, some small percentage of them were software engineers, but 90+% of them were whatever. And in that population is where we first saw 2/3 of what's going on is knowledge. Okay. Then, but I want to rewind back a little bit in history. When ChatGPT first came out, November, I think it was 2022, I don't remember, Thanksgiving, yeah. The first people to adopt it were largely the software engineering community, myself included. Like and then it sort of trickled down to the rest of the world, right? And what I'm seeing is the same thing with agents. So when a lot of my anecdotes were about software engineering, I was specifically talking about the agent case. And I see that parallel happening yet again. Software engineers are just going nuts with this stuff. And now people are sort of like, in the next year, you're going to, this is why this month I'm spending here is so timely. In the next year, it's going to penetrate down to the sort of general public in a much, much bigger way. So I do think that these questions are going to be sort of pervasive past the software engineering industry in spades. And quite frankly, if I didn't think that, I probably wouldn't study it.
Okay.
And then one last point about a historical example, just in case it matters. You and I, judging books by covers, are old enough to remember when Wikipedia came out. I don't know if you, but when Wikipedia first came out, everyone thought the world was crashing down for educators. Like anybody can edit. God knows what this thing could say. People are going to plagiarize. Oh my God, this is a disaster. And then you fast forwarded 3 years, it's like everybody cites Wikipedia, and it was like part of the world.
Yeah.
And the same thing's happening again. This was an idea that came out of a panel I was on in Purdue. And the scholar who came up with this example was that was a genius example. It's like, that's what's going to happen again. In 3 years, we'll figure it out. It's not going to be easy, but we'll get there.
Yeah, I think Wikipedia is a good example of a knowledge commons. Yeah.
Yeah.
So the other question had to do just with the fluidity of the area that you're looking at. When I look at the improvements in AI, it's the hockey stick graph again. Right? So how do you account for that with the work you're doing? Could you tell us a little bit about the snapshot problem?
I account for it poorly. That's how I do it. It's the world is changing in my research domain. The world is changing every 6 months, so you have to be agile with your research. So 2 things. Number one, you have to pick research questions that are both timely and timeless, and that's hard. That's harder than it's easy to say, and it's hard to do. There's plenty of research questions that we've walked away from thinking like, look, models will get better in 6 months, and this research question is not going to stand. So that's the first thing. The second thing is you have to be agile. Like, okay, you think this question is timely and timeless. The world changes in 3 months. Sometimes you got to cut bait and move on. And that's just the way it is. It helps them a little bit more senior or established in my career. For the junior guys, they're stressing about this and they look to us for advice. And I'm working with them on some sort of longer term sort of envisioning exercises so we can place bets on where that future is going to be. And if that's a conversation you want to have, we can definitely do that while we're here. Cool. Sean?
Hey, Sid, this is super cool stuff. I feel like every time we open the box on Gen AI, it's turtles all the way down. It's like
Yeah.
I have a whole bunch of questions. I'm just going to try to stick to maybe the 2 most provocative ones, just for
Sure.
the point of interest. You have the table with the 3 types of
Yeah.
models, and on the bottom row you were kind of asking, this one, the 3 question marks. I mean, just to kind of focus in on that for a second, like. And these are just sort of speculations that I've had, as I've thought about it. Not in a, I haven't published on this stuff yet, so these are just thoughts. But I think we do have theory for this. And you're a computational social scientist. I actually call myself a computational social scientist, and sometimes some crowds. I mean, I think that the social sciences, and I'm talking about them in a general sense, we have a legacy, 150 years of history of this, an intellectual canon. We have social theory, and there's a vast repository to draw on to understand these things. And the reason that's so important is because mechanistically, these LLMs, there's 2 things. One, the analogy, which has been turned into computation, is a neural network, right? It's bio-inspired. Like the actual computational framework for these LLMs are neural networks. So that's one thing.
mm,
it's drawing on
mm,
its sort of human legacy. But then secondarily, they're large language models. So they're actually trained on human
mm,
language. And so in
mm,
anthropology, in linguistic anthropology, I'm sure you know you're going to know what I'm talking about here.
mm,
Back in the 30s and the 40s, we had the Sapir-Whorf hypothesis. This sort of idea that language is culture. That
mm,
human cultures are embedded in the way that we
mm,
speak, the structure of the grammars, the language. There were a couple versions of this. The initial sort of hard Sapir-Whorf hypothesis, was kind of refuted because it suggested that people couldn't sort of escape from their language, and obviously that's not true. Our brains and cognition are quite elastic and
mm,
plastic, and
mm,
they can morph, so we can speak two languages, for example. So it sort of evolved into a soft version of the Sapir-Whorf hypothesis. But I often wonder, like if this could be sort of a resurgence of the Sapir-Whorf hypothesis in the world of LLMs, because ultimately these things, they're actually the LLMs themselves. They don't, they're not. I think we still agree that they don't have consciousness, right? But
mm,
they
mm,
but they're
mm,
instantiating the rules of language that they've been trained on, and those are human languages. And so
mm, mm,
um, so I don't know, just to kind of loop it back around, like I think almost no theory. I think we actually do have a lot of theory, and the
mm,
theory is from the social sciences. Over, it's accumulated over 150 years. So I think that's,
mm,
just sort of stuff I've thought about, and
mm.
maybe it aligns with some of the things that you're thinking about. I have one other question, but I'll
So,
stop at that.
yeah. Let me respond to that. So first of all, great. Thank you for that comment. This is exactly why I wanted to be clear about where I need to do more thinking, and you gave me a avenue to go down. So I appreciate it, and I will. There is one logical leap you're making that requires a little bit of justification for me, and that is just because an LLM is trained on human language, it doesn't mean that it's going to behave like a human, and therefore it doesn't mean that the social science theories apply. That requires proof. I'm not saying it's true. I'm not saying it's false. I'm just saying that requires evidence. Uh, so let's do it. Like, yeah, great. I know what to do this afternoon. Uh, what's your second point?
Interesting. So, I guess the second question is sort of it's more of an applied question.
Mm,
Sort of back to the beginning of your talk, there's this articulation of, a really fast moving knowledge economy. This is like LLMs are like the Uber for taxi drivers, right? But
mm,
for knowledge, for science, for
yeah,
intellectuals, it's a disruptive technology that's changing how, everybody on this chat works,
mm,
I think.
mm,
And even if, even if they don't want it to, like some of all of our colleagues probably, or maybe not yours because you work at Microsoft, but in academia, some of our colleagues are, not using these things. But I think it's going to transform science. That would be my guess. But yet we have this sort of residual of I don't know, 19th century science in academic publishing, all of these kinds of things,
yeah.
and they work at really different paces. So
Mm,
I'm just wondering, like, what you think about this, because sort of like the processes, sort of the processes that science has in place
yeah.
to evolve ideas, theories and hypotheses and scientific. We know peer review is broken, yada yada yada. Um, but what do you think?
Mm,
To the bleeding edge of agentic AI, and coming up with workflows to do to help. Like I want your write a paper workflow, and I want,
mm,
like if I can borrow that from you, what does science look like? I mean, do we have to scrap that whole system
mm.
of how we evolve ideas, or where does this go for science?
Um, okay. The most general version of your question would be a multi-hour debate. But let me answer a very specific instance of your question, which is like you specifically zeroed in on the peer review process, which I totally agree is broken and been broken for a while and will now die under the stress of generative AI. And many of my colleagues have had the same idea, and one of my colleagues even wrote a blog post about it recently. And this might sound nuts at first glance, but the closest framework I can think of to where things might go in a sustainable way, this might sound nuts, is GitHub. And here's what I mean. Instead of writing a paper, like a paper is going to be a human view on your output. But something like GitHub that holds all your data, all the analysis scripts you've done. So let me give you let me walk through this with a very simple example. I'm doing a study with a friend of mine on how does looking at AI startups, how does funding does AI help startups be more lean? Can you get more done with fewer people if you're an AI startup than if you're not an AI startup? So you have this data set of US-based AI startups. And we're going to work on this, and we're going to write a paper. Great. And what you can imagine is when we're done, we'll have a GitHub site where it has all our data, all the analysis scripts, all the figures we did, and the paper. And then maybe somebody else, maybe in France, could say like, oh, wait a minute, I see what these guys did in the US. I can adapt this to the French system of how startups work here. I don't know how they work here. And then they can look at all the assumptions we made and adapt that to the French system and then branch our paper and write that. And then maybe someone else in Japan could do it. And science could sort of go in this way, in a more sort of like collective intelligence, sort of crowdsourced kind of way, than this sort of like peer review. There's a few people on the top of the hill who bless what you've done and view it as gold. So that's kind of like the closest system I know of at the moment that could withstand the strain of what we're going through.
Thank you.
Yeah.
Thanks. Matti?
Thanks so much. So interesting and great presentation. I really like the step from this kind of AI kind of as an assistant, and then moving to more a broader organizational changes, kind of having that the agents have some kind of independent and role as part of the workflows, which I think is the crucial step here that we all need to kind of consider much more. And I mean, it raises lots of ethical questions, legal responsibility, so forth. But I wanted to raise this kind of organizational side of it, even related to questions of management, even kind of disciplining in some sense these new kind of agents. We have been trying to work with different kind of workflow for information extraction from historical sources, and it's lots of interesting things. But what we especially find interesting is that the agents have very different kind of profiles, or the AI models have very different kind of profiles, how they do the task of information extraction. Some are more conservative, some are more bolder in there, and this kind of, if you have different types of agents in your workflow which have these kind of, let's say, features or profiles, or how would you call them? I mean, it's an interesting task for somebody planning and thinking how the organization works. We can make lots of course parallels to kind of human beings in part of these workflows. And also something I wanted to kind of raise is that, of course, it's much easier to follow these agents, even though you cannot open the black box, but we can have a 100% log following each step what the agent has done. This is not the same kind of possibility for human beings, fortunately. I mean, but of course it raises quite scary questions, of course, following what the agents do, disciplining and so forth. So I think the organizational perspectives might be very interesting in your case. Thanks.
Thanks for that comment, Matti. I just want to add one little detail. You're absolutely spot on. You have to be realistic about the pros and cons. Just like any organization, you're realistic about the pros and cons of the employees you hire. You have to be realistic about the pros and cons of the models you're using, not just among the models themselves, but also as compared to humans. And then architect your workflow in that way. And the only way I know to do this is trial and error, unfortunately.
Yeah, colleague Matti Nelimarkka trained a Marxist LLM, so just saw a paper about that. So I was wondering what if the agents start, organizing in labor.
Can't wait for that.
Sense.
Yeah.
Thanks. Really cool.
Thank you.
Thank you very much, Nathalie.
Thank you, Suri, for this very interesting presentation. I have a question about night and day rhythms in the coordination of these workflows and their design. what happens when the workers go home? I assume the agents don't stop working, but there is no human decision making at this point. So how do you see this breakdown of workflow being maybe redesigned or not between day and night cycles?
So I only have anecdotal data here. I don't have, hard data on this. First of all, good question. So what I found is I was looking at it from the human perspective, and what I find a lot when people go deep into this agentic world is they work more, they work longer hours, and they almost feel like guilty if like they're doing something and the agents aren't doing something at the same time. So like I'm being honest here. I'm a little worried about some of this stuff. Like there's kinds of people like I'll give you an example. Like one of my friends, he's like, look, if I'm not with my son, I'm making agents do stuff. And he's like, I check them before I go to bed because I want them to do stuff while I'm asleep. I'm like, I don't know about you guys, but if I did a whole bunch of coding right before I go to bed, I'm not going to sleep very well. So like, I'm kind of nervous about this. And then you're asking me the question from the other perspective, which is like, okay, so the humanists kick something off, the agents are not, and going to sleep. The agents are left to their own. Now what happens? That's up to the workflow architect. They're going to have to instrument their agents to stop, pause, when things get unclear. That's why you need a human in the loop. This is all going to be part of the expertise you need to architect the workflows accordingly.
Thank you very much. And that's about all the time we have. And